Okay, for this preview problem, we're going to take a look at the lifetime of atoms with a half-life of 10 years. So let x be equal to the lifetime of the atom. Then x is going to have an exponential distribution with parameter lambda, where, and we derived this in class, that the natural log of 2 divided by lambda is going to be equal to the half-life 10. And then solving for lambda, we get that lambda is equal to the natural log of 2 divided by 10. Okay, so this was derived in class, and so we can use this to solve the problems of these three problems. So part 1, the probability that x is greater than 30 is the integral from 30 to infinity of lambda e to the minus lambda t dt. So I integrate the PDF of the exponential distribution, and so that's equal to negative e to the minus lambda t, doing the integration from infinity to 30. And so that's the chance that the atom survives at least 30 years, that it lasts longer than 30 years. So this is equal to, plugging in infinity, we get 0. Plugging in 30, we get negative e to the minus 30 lambda. So that's e to the 30 lambda. Now lambda was equal to natural log of 2 over 10. So that's equal to, and I forgot the minus sign up front here. So that's equal to e to the minus 3 times the natural log of 2. And you can plug into your calculator or else use properties of the fact that exponential and natural log are inverse functions. And we get that this is equal to 1/8. Okay, now this makes sense. The half-life is supposed to be 10 years. And so after 30 years, that's 3 half-life cycles. So only 1/8 of the atoms are now left. Okay, problem number 2. Find the time required for 90% of such atoms to decay. How long does it take for 90% to decay? Okay, so before I get going on this, this is 0.125, the 1/8, and so I expect my answer to be somewhat bigger than 30 years. It takes, after 30 years, 87.5% of the atoms have decayed, and now I want, in this problem, for 90% to decay. So I expect the answer to be somewhat bigger than 30. Okay, so for part 2, we want the probability that x is less than or equal to t to be equal to 0.9. Now I can integrate again, just like I did over here, or I can use the fact that I already know what the CDF of an exponential distribution is. It is 1 minus e to the negative lambda t, and that I want to be equal to 0.9. Okay, so that means that 0.1 is equal to e to the minus lambda t, and t is the unknown here. Lambda is known. Taking the natural log of both sides, natural log of 0.1 is equal to negative lambda times t, and therefore t is equal to negative natural log of 0.1 divided by lambda, and we recall that lambda was equal to natural log of 2 over 10. So dividing, I've got natural log of 2 over 10 down here in the denominator. And so plugging into a calculator, we get that's 33.219 years. And so that's how long it takes for 90% of the atoms to decay. Okay, the third part of the problem is actually the easiest. To find the lifetimes mean and standard deviation. Find the mean of the lifetimes as well as the standard deviation of the lifetimes. So problem number 3, the expected value of a exponential random variable is 1 over lambda. And so that's going to be the reciprocal of this fraction, so 10 divided by the natural log of 2, which is approximately 14.427 years. So that's the mean of the distribution. The half-life is 10 years, the mean is 14.4 years. And the standard deviation is exactly the same thing, 1 over lambda. And so that's approximately 14.427 years.